Alright, so we're going to go ahead and take a look at the last page of the test review. Number 20 says find the surface area of the hemisphere. Leave your answer in terms of pi. Okay, so surface area of the hemisphere. This is not going to be on your formula chart. You're just going to have to know this one, okay? So the surface area of a hemisphere is equal to 3 pi r squared. We know what r is. That's the radius. So if I look back at the figure, the radius is 3.4. So the surface area of this hemisphere is equal to 3 pi, okay, so that's the radius, 3.4 quantity squared. And then you're going to go ahead and get 34.68 pi square millimeters because we're dealing with surface area. And then the volume of the hemisphere. What I like you to do first is this. We're going to go ahead and find the volume of the hemisphere by just using the regular volume of the sphere formula. Okay? And then whatever our answer is, we're going to divide that by 2. That's the best way to approach this problem. So the volume of a hemisphere is 4/3 pi r cubed. The radius is 3.4. So 4/3 pi times 3.4 raised to the third power. So I'm going to do 3.4 to the third 3.4 to the third power. Okay, and then whatever I get, I'm going to multiply that by 4, then divide by 3. Okay, so where am I? I got 52.4, right? On your calculator, you should see 52.405333, so on and so forth. I have 52.4 pi, let's say. That's just the volume of the sphere, by the way. But remember, we're finding the volume of the hemisphere, so we gotta divide this by 2. And what do you get? What do you get? You're gonna get 26.2 pi cubic millimeters. That's your answer. Alright, that's number 21. Now, number 22, it says the area of the great circle of a sphere is 32 feet squared. Find the surface area. Okay, so the area of the great circle, just like any regular circle, the area of the circle is pi r squared. So therefore, the area of the great circle is still pi r squared. So A is equal to pi r squared. Right? The area is given. Yes, the area is given. That's pi r squared. And it's 32 square feet. So I'm going to highlight this. This pi r squared is equal to 32. So, to find the surface area, what's the surface area of a sphere? The surface area of a sphere is 4 pi r squared. But y'all, look at that. Pi r squared, pi r squared. Pi r squared is 32, so all I gotta do is just replace pi r squared with 32. So I have 4 times 32, and that's gonna give me 128 square feet. Okay? Definitely would remember how to do that. That's just a quick way to get your answer, just by replacing pi r squared with that number there. And also, please make sure that you remember the surface area of a hemisphere formula, so start that as well. Keep that in mind. Now, 23, where are we? Okay, 23. Find the volume of a sphere with the circumference of 49 yards. Round your answer to the nearest tenth. Alright, so the volume of the sphere formula is 4/3 pi r cubed. But what's our issue? I'm gonna look at the problem, the word problem. Does it tell me what the radius is? Because I do need the radius in order to figure out what the volume of this particular sphere is. I do not have the radius at all. But what it tells me is that we have a circumference of 49 yards. And circumference, okay, well, circumference. It is 2 pi r. So the circumference is 2 pi r, and the circumference is given, right? So I'm going to replace c with 49, which is equal to 2 pi r. That means in order for me to get r by itself, because, you know, again, we need to find that radius there, I got to divide both sides by 2 pi, just so I can get r by itself. So 49 divided by, okay, oh, let me go ahead and make sure, when you put this into your calculator, please, this is how you're supposed to put this into your calculator, okay? So you're going to do 49, you're going to type in 49, and then the division sign, yes, you're going to divide that by 2 pi. So that way the calculator knows exactly what you're trying to do, because if you just write 49 divided by 2 pi into your calculator, just like so, then what the calculator is going to do is it's going to do 49 divided by 2 and then multiply by pi. Okay, so what I'm trying to say is parentheses do matter, order of operations do matter. Okay, so please be careful with that. So 49 divided by parentheses 2 pi, because the 2 is a number and pi is a number. Order of operations do matter, so please make sure that you keep that in mind. So now, what do I get, by the way? 49 divided by parentheses 2 pi. That's 7.8. Okay, so your radius is 7.8 yards. But that's not what the question is asking me. It's asking me to find the volume. So since I know what the radius is, I'm going to do 4/3 pi times 7.8 raised to the third power. So using my calculator now, I'm going to do 7.8 raised to the third power, hit enter, multiply that by 4, then divide by 3. 632. Yes, 632 point, round to the nearest tenth here. So on my calculator it says 632.736. So your answer is 632.7. Volume is the word here, so that's going to be raised to the, so it's going to be cubic yards. 632.7 cubic yards. All right. We got 3 more problems to go, and this is our answer for number 23. Number 24. 2 cubes have side lengths of 3 inches and 8 inches. What is the ratio of the surface area of the small cube to the surface area of the large cube? So I can see here, first thing it says you're dealing with side lengths of 3 to 8. So I am going to say, okay, you got your ratio of your parts. This is one-dimensional, by the way. It's going to be 3 to 8. Sorry if this doesn't look like it says one-dimensional or 1D. Okay, so ratio of parts is 3 to 8. And then my goal is to find the ratio of the surface area. What dimension is surface area in? 2-dimensional. So I have my scale ratio here. This is my scale ratio. What do I do with my scale ratio? Well, just gotta make sure real quickly. Do I need to simplify this at all? Alright, I can just do math, enter, and then I'll still get 3 over it. Okay, good. We don't need to simplify this at all. Let me make a quick note. Just in case, simplify. Simplifying will make things easier. It's just good habit to simplify. But in this case, 3 over 8, you don't need to simplify. So that is going to be our scale ratio. Number over a number. So the ratio of the parts, 1-dimensional, 3 over 8. Gotta convert that to 2-dimensional. So what do? I gotta raise that ratio to the second power. Go ahead and use a different color here. Raise it to the second power. What do you get? 3 squared is 9. And then 8 squared is 64. This is your answer. Number 25. Two similar pyramids have heights of 4 feet and 7 feet. What is the ratio of the volume of the small pyramid to the volume of the large pyramid? Okay, so here are my parts. So, ratio of the heights. What dimension is height in? 1 dimension. And then I can see it's going from 4 to 7. Yes, so I'm right. 4 to 7. Ask yourself, 4 over 7, is that simplified? Yes. If it's not simplified, simplify that. That's going to be the ratio. Okay, again, always simplify just in case. Always simplify just in case. Alright, this is our scale ratio. And what is it asking me to do? It says, okay, what is the ratio of the volume of the small pyramid to the volume of the large pyramid? Good thing that I have 4 over 7, because this is the small over the big. Okay, so, oops, let's use a different color. So, ratio of volumes. What dimension is volumes in? Or what dimension is our volume? I don't know. What dimension is volume? Oh, there you go. What dimension is volume in? 3 dimension. 3D. So, what do I do with my scale ratio? Okay, this is currently 1 dimensional. I gotta raise it to the 3rd power. Okay, so raise your ratio to the 3rd power. So 4 to the 3rd power, what is that? 4 to the 3rd power is 64. Over 7 to the 3rd power is 343. Is that your answer? Yes, that's your answer. Very, very nice. Alright, last problem. Last test review problem of the school year. Unless you're doing your final review, but forget about that for now. 26. Two similar cylinders have surface areas of 40 pi square feet and 90 pi square feet. What is the ratio of the height of the large cylinder to the height of the small cylinder? Okay, so gotta go from large to small here. Okay. Again, what is the ratio of the height of the large cylinder to the height of the small cylinder? Let me go ahead and box large cylinder to the small cylinder. Look, I'm dealing with 40 over 90, yes? So, what number goes up top? 40 or 90? Well, it's going from large to small, so I need to put 90 pi first, because that's the bigger number. Divide that by 40 pi. We have the ratio of the surface areas. Ratio of the surface areas. What dimension is surface area in? 2 dimension. Okay, 2 dimension. 2D. Now, I gotta bring it down to the ratio of the height. Height is, so let's write this down. So I gotta convert that to the ratio of the heights. What dimension is height in? 1 dimensional. So if it's currently 2 dimensional and I need to get into 1 dimensional, what do I do with this? Well, the first thing that you have to do, y'all, is simplify your answer. Okay, I can go ahead and get rid of the pi's, and then 90 over 40, that simplifies to 9 over 4, okay? And just because I simplified it, it's still 2-dimensional. Nothing really, in terms of dimensions, it's still the same. So, 2D to 2D, ratio of the surface area is 9 over 4, alright? Now, I have this 9 over 4, gotta make sure that we answer the question. What's the ratio of the heights? Well, all I have to do, since this is 2-dimensional, in order for me to get from 2D to 1D, I have to take the square root. Take the square root. you're going to get, okay, so the square root of 9 is 3, the square root of 4 is 2. This is your answer. Okay, so the ratio of the heights is 3 to 2. If you were dealing with volume here and you got to convert that to one-dimensional, you got to take the cube root. And remember, if you need to take the cube root, if you take the cube root, by the way, you just need to press Math 4. That's going to help you take the cube root of whatever you need to take the cube root of. All right, I'm done. Bye-bye. Thank you so much.